Here we are again. Back in the dreams streams. Why don't I do the little emote thing? I was supposed to be able to do little emotes by clicking on the pad. Aw. All right. Today ought to be interesting. I've been hearing through the grapevine a bunch of stuff about bit masks for how my friends are solving this one. Dreams doesn't really do that, but we'll see. I have no idea what the problem is. I gotta get rid of these. Those were yesterday's problem, old news. So. Let's get into the problem then. I will switch over to the to my other window. Let's where is it? How do I OBS? How does this work? Here we are. Problem 3. Let's see what we're in for today. Rucksack reorganization. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Is this just a link to like what a rucksack is? Yeah. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. I mean, are they deliberately trying to sound like the knapsack problem? Because like... let's see. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. The elves had made a list of all the items currently in each rucksack. And that's your puzzle input. But they need your help finding the errors. I just glanced at the later stuff and was like stunned momentarily by the amount of work I'm going to have to do to just input the program today, so we'll see. We have to find the errors. Every item type is identified by a single lowercase or uppercase letter. The list of items for each rucksack is given as characters all in a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second. Huh. So if we have the following list of contents from 6 rucksacks, and here we have a bunch of terrible random strings. The first rucksack contains these like 20 items, which means its first compartment contains those items up through here, while the second compartment contains these items through here. The only item type that appears in both compartments is lowercase p. The second rucksack's compartments contain, yeah, and the only item type that appears in both compartments is uppercase L. Oh no. The third rucksack compartments contain, yeah. So, to help prioritize item rearrangement, every item type can be converted to a priority. Lowercase, A through Z have priorities 1 through 26. Uppercase have priorities 27 through 52. Okay, this is fine. Yeah, whatever. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16, 38, 42, 22, 20, and 19. The sum of these is 157. Find the item type that appears in both compartments of each rucksack, and what is the sum of the priorities of those item types? Oh, okay. So you're just... Yeah, okay, so I'm just trying to trying to understand the problem here. Each of these things is basically just a string of undefined length that has one thing in common in the first half and second half of each string. We need to identify what that thing is, and then add that up as we go, basically, in order to get the total thing. And of course, the puzzle input is massive, and I won't be going through that. But even this input is rather large, which is exactly what I like to see. So it's gonna be a fun one today. It's gonna be a really fun one. So let's get the problem up on screen first. I gotta go through that little song and dance. Let's see here. I'm going to have to do this nice and slowly. One tiny piece at a time. So here's our overall input. I'm gonna trim down to just these things, and this should be sufficient to explain the problem, I think. So we will put these next to my face here. Forgot I had that. I should have turned that on before. Okay. So here we go, I guess. Oh no, is this hooked up to somebody else's chat right now? Hold on. my Twitch overlays thing may or may not be hooked up to Ryan Fleury's chat. Allow me to fix this. Hello? Okay, turn off the overlays, turn back on the overlays. Perfect. Exactly what I wanted it to do. Yeah, now we're working. Okay, well, let's get into it. This is gonna be crazy. This is gonna be crazy. So, honestly, I think the first thing that I have to do is encode just a single one of these strings, which alone is going to be just terrifying. So, what I have been doing for these kinds of things is making big selectors, and like having one thing hooked up to each output of the selector, and then I can iterate through that to sort of step through the string. That I'm really not aware of any better way to do it, because Dreams doesn't have any built-in notion of a list. Then, you know, I need some way of like stepping through a whole sequence of values, and those values can be arbitrary. There's no like mathematical formula to it. So I think I just have to suck it up and make like a bunch of selectors chained together. Unfortunately, that sucks because this is longer than a single selector even. So it would probably be wise to start with, well, if I'm going to get the actual answer, I need to get the actual answer. So we'll crank this up to 10, which could do V, J, R, W, P, W, T, W, J, G. And that didn't even like I'm gonna need this many just for one of these strings, if I'm not mistaken. Which is just wow. I mean, that's special, you know. And as for like the values passed into them or whatever, the values that are being used here, that's going to take a lot of wiring by hand. And also I have to figure out some way of like stepping from one selector to the next, which is deeply frustrating. But I think that I can I think what I need is like, let's see, I'm gonna grab one of my memory cells. Wait, what about like my stuff? Can I like, huh? I thought there was some way of searching for, oh, literally just go down from the search. Okay, that's all it is. Memory cell. So this can store a number, and I'm gonna have to use this, I think, to step through all of these. So what I can do is wire this thing into the active port thing, so that, you know, if this is storing a value of 1, then here, let me just grab some value to put into this for the sake of testing. And I think I'll need to power up that save thing just so that it's constantly setting the value. And now, yeah. So this can be used to cycle here, because unfortunately I definitely need to be able to step to the next with sort of a single index value that I'm incrementing over here. I also just know that I'm going to need the old wide calculator here to sort of sum up the total. That's not what I wanted to do. To sum up the total number of ports in this whole program. So, gotta grab these and pull them all together into this. This is just a value I'll definitely need later. Looks real nice, real nice. And for these, I think it's going to be like, I need it to be that each of these selectors are like powered down when they get to their, like, when the index moves on past the final state. So each of these, for example, is going to need something like, you know, this should only be active when this is 0 through 9, and then when it hits 10, this whole thing should be powered off. So to just hack that together for 1, I'll find the pattern later. You know, if it's greater than or equal to 10, then, or no, I guess I want this to be, I'll say if it's less than 10, because it needs to be the power on signal. No. Hook up to power, thanks. So now it's on up until here. Let me get rid of the decimal point on this thing. So then when it hits 10, it powers off. Similar logic for down here would be that it has to be between yeah, whatever two values. And I can't really think of like a great way of simplifying this, if I'm being honest. I kind of feel like, because I don't think that there's a like a range thing here. So I'm just gonna suck it up and do greater than or equal to 10 and less than 20. And I'm going to have to do this for every one of the strings in this thing in order to actually compute the like final result of this problem. So that's great. I love it. And then the active port on here is going to be that value minus 10. I mean, I think this is, yeah, this is working as intended. So now I only need to do it one more time for this selector down here. And then I just need to wire up all the values for each of those things, and then I'll be good. Let's see, I should, what are these weird vocals? Get out of here with that. Weird music, weird ethereal music. Okay, so I'll put these a little closer to the relevant parts of the program and do the same for these down here, where I need more space down here, imagine that. This is now going to be minus 20. Did I wire that up to the right thing? Active port, I did. That's wired up to power. And then all of these are wired into this. This is looking great. Did I screw this up? I didn't change the values on these. So this should be greater than or equal to 20 and less than 30. I'm sure in theory this could be ever so slightly cleaned up, but there we go. We've got ourselves a 22 value selector. Oh dear. Oh dear. Well, this is fine. This is just fine. Come on, move there. Which means that we can iterate over it. You know, the iterator thing should actually still work. The only catch is that we are going to need, well, let's see here. Let me grab my iterator thing from yesterday. And we can start to use this to drive this whole system. So if I pull this way back over here, because this is going to be the value for total. It's the total number of cases we have. We have the current value, which is this. Although, no, this is correct. Current value, and then our time scale can stay 1. Well, I'll grab this. This will suffice to slow it down for our inspection. If we put it somewhere around 10, that'll have like a, I'll put it a little lower, nearly a 1 second sort of iteration time on it. For use, that just means this sucks so bad. All of these things need to be like powered on simultaneously when I have this use signal out, which means that I kind of should have had everything on its own microchip to start. Live and learn on that one. So we'll need a node coming in for, like, I'll call it current. Sure, there it is. And then I can just move all of these. Oh gosh, I need to like break all these wires. I'm just gonna delete that memory cell and we'll grab another memory cell in a bit. Because I'm not gonna delete all those wires and run all the new ones. It's bad enough that I have to run all the new ones. So here we go. Wire this up to everything. Arguably, I should be putting little subnodes on some of these just so that I have a little something extra for wire management. And as for, I kind of want to move this onto the graph too. We'll just like make space for it up above or something. I should really put a name on that one. It's going to be an output node named total. And we'll wire that up to the total port there. Cool. So, hook our memory cell back up here. Current value goes in here. So here now we should have this thing pretty much stepping through when we like, no. Yep, that's still working. As for the iterator though, the iterator is down here pulsing already, and I need to start actually using that. So instead of just that slider that we're gonna put in and this switch for setting it, we want the next thing to, well, we want the new value coming into the cell to be 1 plus the value currently in there, right, an increment. And we only want to set it when this thing toggles to next. In order to avoid setting things continuously, we do the thing where we turn the next signal into a pulse. And then that should basically be fine. So if we run this now, You can see it stepping next, 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 and I can speed it up somewhat like so. Good. That's great. Why did it stop there? Is it done? Why did it stop there? It wasn't supposed to stop. It does think it's done. Why would that be? Oh, because these things are outputting 0 because these nodes are powered off. That's terrible. Wow, so it thinks there's only 10 items. I mean, I can just hard code it per program, and that's honestly maybe not so bad. It's kind of a pain, but hard coding stuff like that is honestly not the end of the world. Yes, I'm rationalizing. "22 items. So now if I were to restart it, and we'll let it go a little faster here. Step, 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 and done. So, I mean, that's great. That does what I want it to do. And this will, more importantly, actually allow me to select the now 22 things that I have to input. Oh my god. Wow, I mean, I guess there aren't that many words to start with RUC, but I'm amused that it has rucksack in its dictionary. So I mean, that works, right? Like we're that much closer to actually stepping through the whole program. So now I just need to encode an absolutely terrifying number of these. So this is going to go 1 to 52 for each of the letters. Where it's like A through Z, basically. Lowercase a through Z and then uppercase A through Z. This is gonna be really annoying. I'm curious, is there a way to display text? Like, does Dreams have some kind of internal text thing? I really suspect that it doesn't, does it? Like, some way to convert a number into text. Like, some way at all? Like, any way at all? Please? So that I don't have to do that mental math all the time? But I'm pretty sure there's not. Well, here we go. Here we go, making strings in a visual language that doesn't do strings. So be it. I definitely need something that like can convert here. I'm going to take the liberty of writing a small real-life program, like, which is to say a JavaScript or Lua program or something that can take one of these strings and tell me the sequence of numbers that it corresponds to, because otherwise it's going to take me way too long. I'm just testing something out on the side here, and then I'll come back. How do you go back? Let's see. is not what I want. Oh, wait. Huh. Well, this'll do well enough for now. Let me click over to what I'm doing over here, which is trying to write a little Lua script that would do this for me, because I have it on hand and I think it would probably work fine. This thing does seem to be printing out the ASCII codes for me. So this would tell me the numbers for, I think, the, like, you know, if I switch this to B, then I should get 2. Yeah, so it's just going through the first character in the string. Now, does Lua, if I do, like, what do I get when I do that? Sure, fine. Let's grab, yeah, let's just do the string ABC for now. Yep. Oh, good. That's right. Maybe this is a bad idea because it actually runs super slow, because this is like designed for, I use this tool for teaching my robotics students programming, and so it actually deliberately runs kind of slow in some ways, which makes this kind of suck for this purpose. But it's not the end of the world. It's still gonna save me time. But naturally, the uppercase stuff is going to mess with me here. I'm gonna just really wildly cheat here. I think, oh no, that's not gonna work, is it? Or this should work. So is that accurate though? Oh no, it's not. There, this should be accurate now. Where I'm pretty sure, yeah, so the letter J is A, B, C, D, E, F, G, H, I, J, 10th letter. So yeah, 26 plus 10 would get me 36. So yeah, I'm pretty sure that this is now working. So I can copy from this now into Dreams. Here we go. And let me save this one and get it on screen. Let's see. How do these compare if I shrink them down? They are smaller that way, but they're harder to enter values into. So I don't know. Oh, hey, thanks for the raid. I'm still entering the program. And it's the worst because they decided to give me 22 plus character strings as the example input, which is another double iteration thing that I have to do. And since Streams doesn't have a freaking list type, I have to... It's going great. I'm currently just slowly and painfully entering the list of numbers you see on the right as a gazillion value sliders. So, yeah. It's almost like they didn't design Advent of Code around dreams or dreams around normal programming. $49. $20. And like, I'm pretty, I guess, okay, maybe the one thing I should do is somehow check if the text displayer can do something funny and show me the like character that is being output. But I don't think it can. I don't think that Dreams lets you introspect on text at all. For those who are joining from the raid, if you're sticking around, thank you for sticking around. I am doing Advent of Code in Media Molecule's game Dreams for PS4, which you may only know in sort of a meme context from the videos that you've seen online and stuff. It is a really interesting visual programming system, and I'm doing Advent of Code in it just to see how far it can be pushed. But stuff like this is the actual worst. So, you know. 749. 18. 8. 3. And the worst part is that I'm not even done with this, because for each of these I have to hook up the power. So like, hook that one up, hook that up. It's a staggering amount of manual work for every single one. Are these wired up to the same thing? God damn it. Why? Why are you like this? I'm absolutely gonna get so many bugs just from like miswiring something. It's just horrifying. But this, I truly know of no better way to do this. There's your first 10. Thank you for the luck. I appreciate the luck, and we'll need the luck. I mean, it is at least, you know, stepping through values, so I got that going for me. I just look forward to doing this 6 times over. Alright, well, more. Embiggen program. Here, I can probably copy down a swath of these. Let's see, 3. We left off at 18, 8, 3. Then we need 19. 32. 39, 39. 6, 32, 32. I guess I need 4 more. Is that right? Six, 32, 32, 8, 32, and 16. Wow, where am I? And then we resume hooking up all the power. That was not right. That was not right. You know, when this whole thing started out, I was kind of hoping for more of those problems that were like cool little simulations that are just like, oh no, did I miscount? How many characters are in this string? Wait a minute. Oh, it's 24. God, okay. Gotta bump this all the way up. Convenient that I randomly picked 24 for that. Cool little simulations would be right in Dream's wheelhouse. You know, stuff where you can do a bunch of like concurrent execution instead of extremely serial execution. But alas, that is not what has been given to me, so I have to make do. We'll just try to, we'll just sort of feebly try to organize this slightly better. Okay, so does that like step through them all? Oh no, it clearly doesn't. Did I just forget to do this one down here? No, I somehow wired those two up to the same thing. Oh boy. Okay, now let's try it, shall we? Progress, kind of. Now it's time to actually wire all of these together yet again into an output node, which I will call value. There we are. Which is more manual wiring, but the last manual wiring I have to do for this specific string in the execution of this entire program. So, you know, small comfort. This makes you really appreciate strings and lists. You know? I love lists so much. They're such, they save you so much work, you know? Well, okay, that is all now conveniently contained right in here. We've got this value coming out. And that means that finally I can hook up the done component to, oops, I need to negate that. To this, and why didn't it stop? Why did it not stop? Why is it still going? Oh, why are you doing this to me? Are you not getting the... Is it because it's like powering down when it... Hold on. Why is it not... What is the value of this thing currently? I'm sorry. Why is it just skyrocketing? Why? Why is it not stopping? 23.9. That's not... Wow. Screw this stupid value slider that apparently has a has a maximum value of 23.9 but is rounding to 24 to screw with me. That's really kind of it. So if I restart this thing now, does this actually work? No, it still doesn't actually work. So I'm sorry, this thing is still reading 23.9? Is it still reading 23.9? No, now it's reading 24. Wow, that's actually terrible. Okay, there we go. Now it actually works. And furthermore, I want to put... Hold on. I actually don't want to undo all that since it's apparently more than I thought. But I want to put these back up in here and make sure that it still works. And I think it should still work because when it kicks to done, it's done. Yeah, that's great. Okay, so that now lets me click through the whole program. Abusive signal, yeah, no kidding. No kidding. So, with that done, now I can finally start doing some actual programming because now I actually have a value coming out the other side. Let me grab a clone of one of these value sliders just so that I can preview the number that is being output from this system. Here, let me switch to this. Seems good. The 1 coming out is a little strange. I'm not sure where it's getting 1. But who am I to say? Oh, the 1 is because that's the maximum value allowed displayed on the slider. So it is in fact working. So time to actually now do the thing. Except the thing sucks. Let's see here. So my issue now, now that I actually have to start writing this program, is that I have to iterate through half of it. I need to find the values that are in common between these two. Which, like, how am I gonna store, like, the values that I have in common. Like, I know that there are 52 possibilities, and like I could certainly make an array of 52 and have like counts for each of those. It's a horrifying concept, because of the sheer amount of wiring that would take. If there's some like mathematical trick, that would be cool, I guess, but I don't exactly know. I mean, like in a normal programming language, right? There are many ways that I could approach this, right? I could very easily make an array of size 52, an array of ints for counts that like, and just go through the first half and second halves of the string, and like, or an array of pairs or something, right? Like I could go through the first and second halves of the string and sum up how many of each character that I saw, and then iterate through the whole thing at the end to see if, which of them actually had values in both slots, right? I guess I wouldn't even need counts. You would just need like an array of bools, or an array of two bool tuples or something, right? I saw it in the first half, I saw it in the second half, loop through and find all the ones where A and B are done. You could maybe like sort the first half and second half of the string separately to like figure out, so that then you could sort of like iterate through both halves simultaneously, and use that to, I mean, I still don't know exactly how you would do that, but I imagine that you would just sort of like have two cursors stepping forward, and like whichever character is less, that's the string that you bump forward or something. And if they ever equal each other, then that's your answer. That could be reasonable if it weren't for the sorting part, because I really am not about to implement a sorting algorithm here. I have no idea how I would do so. I don't have like any way of sort of dynamically changing the values that I've got in here. I mean, I feel like I would need to somehow, like, what would I do? This is maybe something I should figure out, because it seems like sorting data is a valuable thing to be able to do. But I mean, accessing data this way is nonsensical. I mean, I guess I could. I've essentially got a list here, right? Like I pass an index into it and I get a value out. I could somehow build into this the ability to set values as well. I hate that idea, because like, how would that even, I'd have to replace all of those with memory cells, and I'd need to use I'd need to have two modes on it, and but I could in theory do like an insertion sort or some other kind of sorting algorithm that way, right? In my case, I think it would be way more work to sort this data than it would be to just process it unsorted. I don't think that this problem needs a sorted list. And given that I don't have, sorted array stuff on hand, I feel like I should just go with something that counts individual things. It's getting warm in here. I have to have my office door closed when I stream, and so it's probably not that different if I need like an array of 52 Boolean pairs, though. Like it's all shaping up to look terrible like that. So is there a way to sort of divide and conquer this? somehow. To like I could one very low, inefficient, low-tech way of doing this, I suppose, would be to iterate from 1 to 52 and go through go through each string and be like, do you have the value 1? And then into the second half, do you have the value 1? And if both are true, then I know that that's it. And then I go to value 2. Do you have it? Do you have it? Then the 3. Do you have it? Do you have it? This is obviously inefficient, right? It multiplies the whole runtime by 52. Although, I mean, other solutions are going to involve more iterations through the list. I might have to see how, but that approach would work. I mean, it's bad, but it would work, right? So I'm sort of curious how fast I can make the iteration through this list, right? Like I can go faster than that, right? Let's add decimal points to this and see how low I can go. Because this is sort of the default speed. That seemed to work. Let's drop it to 0.3. That also seemed to work. There'll come a point where I can't go faster because I'll get like, it'll like land weird on frame boundaries or something, or like I don't know, it seems fine so far. Yeah, see, now it's like stuttering. So we're gonna try it out on something a little slower that I have more confidence in, because that looks pretty good to me. That looks like nothing is going wrong, right? That's just iterating nicely through everything. And like the reason that I need this is because this signal generator thing is clicking through, it's going on off that quickly. And it seems like it's nearly going every frame at this point. I mean, maybe not quite, but it seems like this is working okay at 0.3. So we'll run with that for now. So let's oh, I need to build a reset into this iterator. Okay, sure. Because it just kind of goes right now, but I'm going to need to Here, let me, oh, I can hide that thing now. I don't need that anymore. Here, hold on. I need to save this creation. It is a scene. It is a showcase. And it is called Advent of Code 2022, Day 3. Rucksack reorganization. How kind of it. Save me some good typing. And now let's jump into edit the source of the iterator. So this iterator currently has no way to reset to the beginning state. So when we do this, what we basically want, I mean, it's mostly as simple as kicking back to input A here. Because if I like, here, I actually need to set some dummy values on this. Let's see here. Let's say that we have to get up to 5. Oh my god. Total is 5. Current is, well, it's gonna be whatever. I'll change this to go 0 through 4. Through 4. God, I hate this so much. And I'll wire this. Let's see, I need to actually get rid of the decimal places there. So this is going to be pulsing away, and it's going to tick through until it gets to there, and then it's going to click through the remaining states until it stops. But then what we want is the ability to reset it to here. Now, why it isn't... Okay, there we go. Yeah. So on reset, it'll... Actually, that seems mostly okay then. So I think the main thing is that it's a little funky. The way that this signal generator works... Actually, you know what? I need to test something here. I'm gonna wire this in here and slow things way down. So now it's like ticking every 2 seconds or so. And I am going to hook this switch up to the signal generator power because I want to see something. Oh, interesting. So it like pauses it when it doesn't have power. That is what I wanted to see. I wanted to know if it would like reset. Okay, I could forcibly set it to 0 when we get the reset signal, and that would actually work fine. Although, how well does that work? Because now it doesn't play. I'm not even sure what it's doing, frankly. Because it doesn't play automatically if that thing is wired up, which kind of is a no-go. So that's unfortunate. I think what's maybe more reasonable to do is just to wait until it's sort of at its high position again, and then use that to step back into the reset state. So what does that look like? How do I do that? I mean, I think it would more or less be certainly going to be something like this. You know, are we hitting the reset button? And is the signal high. And then when it goes high, it'll kick back into its using state again. And then here, I'll speed it up slightly. It'll tick through all the values until it gets to its done state, at which point it's just ticking off, and this value can go back to 0, and it's still done. You can see over here that the done light is on and the next and use lights are off, indicating that the iterator is complete. However, if we then reset it when we're in this down state, then there, that'll reset it back up to the beginning. And in fact, okay, so yeah, that's, you do want this thing to power off relatively soon, so that's interesting. There's some weird statefulness to this, which, like, because if I'm gonna have this play nice with other parts of the system, then and to work well sort of at speed, then I'm gonna have some stuff to sort through here. So what I feel like we actually want is for there to almost be a reset sequence where, like, hitting reset, even just pulsing it, will toggle you into this resetting state. And then when the thing is next high, that will kick you into the this state, which will set you back to this. Does that work? Because now the implication of this is that I can, here, let me set the value slider back to 0. So it's ticking real slow right now. And then, you know, it'll iterate through to its done state again. Now it's stuck in its done state. And even if I pulse this thing while it's off, it'll sort of wait until things wrap around again to on, so that we always start with the right signal. I mean, that seemed good. Yeah, so those powered off now. And then, here, let's see, what happens if I reset it while it's high? That's the thing that I think is bad. I actually think that we want it to wait for the low and then the high to ensure that we always have a full sort of tick of the high. So we're going to, I think, not wire that up directly. We're going to have, if we're in this state and low, then we'll go to state C, at which point we will wait for the input to be high again, and then the whole thing can reset. So we're in done right now. I'm going to pulse it quick while it's in the on state. So we're waiting for low, now we're in the C, and then we wait for high, and now we should be able to iterate through to the end like so. I'll toggle it while it's down this time. Oh, that kind of jumped right across. That's fine, actually, I think. Okay, well, this might work. I'm gonna get rid of these things. They'll toggle a little faster. And let's just see if it works sort of at speed. Oh no, actually that I'm getting rid of the time scale first. Let's see if it works at speed. So we want to reset this. I guess that worked. So now it's done. Seems like it's working. Seems good. Seems like this is resetting the way I want. So I'm gonna clear this out, clean up the graph slightly. I mean, I hate this, but here, I'm going to make a new microchip on this that we'll call reset, just to sort of keep this contained. This is the thing that can have these all on it. It's also going to have its own copy of the NOT gate here because I want that to be wired in here instead for clarity of wiring. I really just want this thing entering this node. And as for what was that wire coming in? That's basically the like did reset. So I can maybe copy that down. Did reset, and this one is, I guess, just the signal. And now this ugly duckling of a node can just float up here. Oh, I suppose the other thing that we need is the reset signal to actually come in, come to think of it. That seems important. Because that one is the thing that goes into input B here. So let's grab another node down here and call it reset. And that is what's going to wire into here. Although I kind of want another explicit node there to make it clearer what the connection is in case of later terrible wiring. So, you know, this is great. This is great. Clean up our wires just a little. All right. Well, I think we now have the ability to reset our iterator. So we will close right back out of this, save that. And let's see if we can now use that in, I gotta update it first. So I should be able to hook up a switch now to try and reset it, just to probe if this whole resetting thing actually works. So we'll pull this up here. Actually, let me pull this off the board so it's real easy to hit. Big frickin' switch that when I hit it should allow us to. Great. Damn it. Why is it not resetting? Come on. Come on. I mean, it looks great except for the part where it doesn't frickin' reset. What did that do? Hold on. Let me slow it down. Oh, right. I have to reset the count myself when I do this, which is annoying but doable. So I think that is my issue here. So basically, I don't think there's anything wrong with that. The problem is that the like index of iteration is something that is always kind of necessarily outside the iterator, which I hate to say, but that's how this iterator thing works, right? It just like you tell it what the like current value is that it's on. I mean, I suppose theoretically it could work differently, but in order for it to be sort of, actually, let me think this through. Is there any reason in anything I've done not to store the iteration index internally? I actually don't think so. So I should probably do that so it can output the number that you should be using instead of just the use signal. Well, I guess in addition to the use signal, because if it outputs 0, index 0, you do need to capture that. But since you have to pass in the total anyway, and because the index stuff kind of requires you to, yeah, okay. We're going back in here. More work on the iterator. So that means that I'm going to be adding a memory cell to this. Such that, oh, and I'm not going to actually use this next thing anymore. I know it is literally going to be a full-blown computer. It's like, it's kind of terrifying. So I'm not actually going to have this next signal anymore. That's going to be like an entirely internal concept. Let me play with that for now. So I'm going to start by making this actually not an output port. This is just going to be the like, the value next is going to then feed back to actually set the like next value of the memory cell here. Because the memory cell needs to, it'll start out at 0 automatically. I mean, that's just what it does. As I did before, in, outside of just this cell, I need to actually pass in the value 1 plus the current value. And I need to have the signal manipulator to turn the set signal into a pulse just to ensure that we don't accidentally like set it more than once. Because if you leave it on, then on every tick it increments. You don't want to do that. You want to only do it one time. So basically next is going to feed in there and like be used to increment this. Now if I view this, and you can see it ticking up, right? It starts at, I guess that's not super helpful, is it? Easiest way to preview values is basically to just like drop some kind of node on it so that you can view the value like right here. So that ticks up. When it hits the maximum, then so yeah, and in fact what that means is that you're not going to pass in the current value anymore. That will just be contained. I'm going to need a new output, I suppose, which is index. And that's going to be the current value of this. And that is really only going to be active when so that'll be active along with our use thing here. In that when this thing ticks over to done, then we want it to stop. So let's add a total on top of this. I need to just add another number slider to control. Here, I'm gonna keep it on the grid. There's no reason to have it outside. So yeah, this is going to represent then the total value of things that we're iterating through. So maybe we're going to iterate through 10 things to start. And actually, let me use this to visualize it instead. Yeah, so I mean that seemed to work actually. Let me also control the time scale here. Slow it down. 3, 4, 5, 6, 7, 8, 9, and then it clicked to done. Did it click to done quite like I wanted it to? Here, let me speed it up slightly again. 8, 9. One, 2, 3, 4, 5, 6. I should drop the max, but yeah, I think that did. I think that did work right. However, then I need to have a switch passed into reset so that we can try resetting. And resetting is going to be a little different because resetting on its own doesn't really do what you want right now because it just causes it to just iterate past the end instead of resetting to 0. So what we actually want, sorry, let me answer your question here. Is there versioning for parts? It is not going to break the previous day that used iterator. It does have versioning, and you'll see that whenever I go back to a previous creation after I dive in a layer to edit something and then jump back out, I have to go into the update mode where I have the option to update instances in that current scene to the new version, and it doesn't do it automatically. So it should not break old stuff. So I should be free to just keep making new versions of this iterator. So what I need to do when this reset signal trips is actually set this to 0. So what I'm going to do, I think, is just have a NOT gate on the reset signal that powers this thing, so that when we're resetting, we will be feeding the value 0 into this necessarily. And I guess we also want the that signal to go in there. I mean, does that work? I feel like there might be some need to wire the reset signal into the output stuff. So right now reset is on, so because yeah, I feel like if reset is currently active, then like none of these things should be powered. Like, am I crazy? 5, 6, 7, 8, 9, 10, 11. What? But the max is 10. Why did adding this suddenly cause it to go above the max? What? What? Here, I'm gonna drop this to 6. Okay, it stopped that time. When I reset, it's now at 0, and we're going to let it 3, 4, 5. Okay, no, that stopped correctly. I should be able to leave it on for quite a while here, and when I let go of it, it's still, yeah, it should be using the usual synchronization too. Something seems a little wrong there. Which I think is that, I think it clicked to the... Here, I need to, let me slow this way down so that I can sort of get my bearings on this. So basically, I want to make sure that you get like the same amount of time on the first use signal every single time. Like, because when you hit reset, that goes through, oh, come to think of it, I really need to wire these all into the reset node instead of just into this switch. Because like, that's the thing that's actually used once I delete this switch. But if it's super slow now, right? So it should, well, first of all, it iterated past the end again, and I don't know how it did that. I guess it's probably because I was messing with wiring. That's probably not that surprising. So, you know, 1, 2, 3, and it should basically, like, when it hits 4, now it's entering its end sequence. And there, yeah, now it's done. So, that basically is working correctly. When I reset this, 0, yeah, and then use, oh no, that is actually working just fine. I'm pretty sure that my reset logic is actually working fine. 4, and then it goes into the last use, and then it's done. And now it'll do a use on 0, and then it increments to 1, and then a use on 1, and then it increments to 2, and then a use on 2, and it increments to 3, use on 4, and increments to 4, or I may have gotten out of sync there, but I'm pretty sure it did the right thing. And that does reset it back to 0 just fine. Yeah, I think that's working great, actually. Okay. Well. Here, actually, let me get rid of the time scale again. So it just bumps up to 4, and then I can reset it, and it bumps up to 4, and I can reset it, and it bumps up to 4. Okay. Let me just now clean up wires. Yet again, my favorite thing, cleaning up wires. So this little preview is fine, I think. As are most of these wires around here, except that I kind of want this reset to sort of run a lap around the whole system vertically. And as for that like current value, yeah, I should maybe move this down. There's probably no reason for that to be all the way up there. It's kind of confusing that you can't see that one. I'll probably do that just to clarify. Yeah, man. These reset signals, I'd kind of like those to follow along with the other stuff I'm doing, so I guess I'll this little wire run up here is very annoying to me. But I think we'll just do this. Just sort of peel them off and send them upward that way. Beautiful. Thing of beauty. Gorgeous. Love it. Let's quit back out. Save that. Going to update mode and do the update. Okay, you can set it to auto update, but for script stuff like that, I kind of think I'd prefer it not to. Okay, so now this is all different. We have now we have no need for this memory cell because we now have the index passing into this thing instead. Yeah. And this thing, yeah, so now just have total, time scale, and reset. So we have our reset switch now. And this now, here, we'll speed that up again. There we go. Then we can reset this. Okay, so this isn't exactly what I wanted. It is actually powered on telling me oh no, it's not, because I'm not using the use signal anymore. Wait, where was the use signal going before? Oh, it wasn't. That's why. There was only the use signal. That was the only thing coming in here? No. Oh shoot, what was I doing before? I mean, I think I know what I need to do, which is to like well, I guess the use signal is only actually used elsewhere in the program. So this is fine. This is fine. It's whatever. Anyway, then when I undo that, it iterates through again. I can even interrupt it midstream. I can't. Why doesn't that work? I thought I would be able to do that. Not that it really matters. Yeah, sometimes it's not setting to 0. I thought that toggling reset on here would definitely switch it to 0 every time, because powering this on turns this off and would set the pulse on this. But I think what's happening is that I'm frequently checking this on like the second frame after. Yeah, I think I know the fix for this. Let me go back in and make one more small edit, which is to simply not reuse the same signal manipulator for these two different things, but to have another one. I need another pulsinator, basically. So, should be pretty easy. I just have to, you know, rerun all these wires. And then make some minor adjustments. You know, pull this wire up higher again. So we'll just quit out and save that. Boy, I'm 1 hour 40 minutes and I still have not really done anything except iterate. This is great. Hey Eric, you haven't been able to watch one of the Advent of Dreams streams up until now. How successful were the previous days? Pretty successful. I tell you what, I will take this opportunity to hop out of this creation and show you yesterday's. Yesterday's was the rock, paper, scissors game where you have an input that is like a rock, paper, scissors thing. So paper versus rock, you win, that gives you 8 points. Rock versus paper, you lose, you get 1 point. Scissors versus scissors, that's a tie, you get 3 points, or 3 for scissors and 3 for the draw. So 6 points, that gets you up to 15, so 15 is your answer. Did it. And if you dive into the edit on this, then you can see how all that works. The program is all in here. Relatively straightforward. This is your each of these sliders represents rock, paper, or scissors, so I could make the whole thing like, you know, I could change up the game so that it's like I do scissors against paper, then it's rock against rock, then it's rock against, or scissors against rock, so that I should win one, tie one, lose one, and if I run that, then scissors versus paper for 9, rock versus rock for 13, and scissors versus rock for 16. So that all works. Also, these are controllable characters, and you can just goof off, which is really fun, really good. Today is going much worse. So the issue here, don't save anything. The issue is that Dreams is not good at lists. It doesn't have them. And this problem, like if you look down here, you can see that big lists are in fact, like big strings are the essence of this problem. And so every one of the characters of that string is set up over here, and I've had to like stretch the like iterator thing that I use in Dreams to actually like work with more things and to be able to reset. Yeah, now that's working well. So I can reset my iterator anytime I want. And here, let me drop that down so that it's much faster, which I think will be important. So now I can iterate through a list that quickly. Maybe faster if I really tried, but you can only really go so fast here before things start stacking up on the same tick in ways that the whole node system is just really unhappy with. Dreams doesn't have execution flow, so this is what you have to do. Stuff like this. So that actually seems really good. Why though is it not saying that I'm done? That's somewhat concerning to me. Why is it clicking back? It's not. Why? How long am I going to spend on just iteration in this stupid system? What is causing it to do this? Here, I can speed it up somewhat by pulling this back. It is functional, kind of, in the sense that, like, stuff just powers on and powers off and sends values from one to the other. Each node kind of does whatever with the input signal, so there are little like stateful things where it's not like functional in the way you might be thinking. Is that stuff like this selector here, they have state. They're, you know, nodes can have state, and by sending signals to them, you can, you know, change the state of them, which is how you can get sequences of behavior and other stuff like that. Fourth Wind, how are you? It's been a long time. Yeah, well, the later days in Dreams, I mean, I plan to do this for the whole month pretty much, but like some problems might literally take me days to complete. So like we'll see. Anyway, hope you're doing well. So why is it? Oh no, it didn't. It didn't power on this time. It stayed in the done state. So what I'm looking at here is that you see how this whole canvas goes dim? That's because it's powered down. When iteration stops, it's supposed to be powered down because this done signal is on. Now, if I speed it up, apparently that maybe doesn't always work reliably. Well, now it's working fine. What was wrong before, huh? God, who even knows? We're gonna take it up to a moderately safer speed. That is not nearly as fast to iterate, but oh, and thanks for the sub. Appreciate it. Inching closer to that Twitch payday. Okay, well, hey, this I'm gonna call this working for now. This is unfortunately just one extremely small part of the problem. That's the worst thing about this. It's actually like it's actually just not a lot of the problem here. I'm also, you know, the other thing that I'm wondering is if I should get rid of the built-in signal generator in the iterator, because I think that this is actually going to wreak havoc in some ways, because I don't actually want that for... So here's the thing. Here's what I want to do now. I want to sort of compose two iterators, because the really dumb brute forcey way that I've thought to solve this problem now is to well, here, let me I wanna sort of power this on first just to see if it's... Yeah, that's working nicely. I realize the flickering is maybe a little bit obnoxious, but that is doing what I want it to do. So what I want is to iterate through this string multiple times, and to like say that I want to actually iterate through this string 3 times. Well, what does that look like, right? So that would mean that I have to like manually pass in the value 3. Well, here, let me control the min and max on this. So let's say that it's 3 times that we're going to go through the entire thing. The problem is that it's going to naturally click up to done right away. It's just like, and 3 things done. But I actually need to like step it when the previous iterator finishes. So, is code reuse possible in Dreams? Will the current iterator code be useful for the next days? Yes. The iterator that I'm using here is built on the iterator that I used yesterday. And in fact, like, I can dive in and make edits to this thing, which is like a separate scene, simply by selecting it, do edit source, and it'll sort of hop me over to the other program, other, you know, scene, the other element, whatever it happens to be. And then you can make changes, and then you can hop back out, and then it gives you the interface to update. Oh, Eric, thank you for the sub as well. I missed that. Thank you. So I think that actually I should pull out this timescale stuff entirely. Like, I might make this into sort of its own little convenient node on its own, which is just the sort of like just sort of a clock that I can use to drive various things. But as for this specifically, then I need to actually have the like use and next signals, like or sort of the input signal, like input clock, be different. How do I actually want to do that? think I probably want the next thing to be like just an explicit signal that I send in. So instead of all this timescale-y stuff, here, let me start by just pulling the clock out into its own node, which will be yet another good example, actually, of how it works to do that sort of like refactoring, so to speak. Also, I think that for convenience, in this node, I can put a couple output nodes that are like high and low. Then I can, or I guess that's not really like, oh no, this is stupid. What am I doing? Does this help anybody? I mean, I think it kind of helps, where it's just like, yeah, so when the signal's high, yeah, no, this is actually fine. So once I tidy this up a little bit, okay, this is a little gross because I need to rewire a bunch of this stuff, because this is gonna go, I mean, a bunch of these wires are actually not gonna stay because I'm going to be making the next stage of the iteration work a little differently. This actually is that like low signal, so that is going to feed into these. And beyond that, I think I am good to delete these wires. And this. So that's sort of my clock, and in fact I could name this like just clock. And this can be saved as its own scene. It is a contraption called clock. And that will make it its own thing. So now it's actually saved as a separate instance of stuff that I can use elsewhere. But I gotta now think through exactly what I want this to be, because I think now I'm just gonna like, I'm gonna keep the clock here like for reference, but I kind of just need to get rid of it. So we're not gonna have timescale anymore. We're going to have next. When you send a signal on this, it will tick the iterator to the next thing. So previously that was done by the low signal here. So I feel like there might be some stuff required to make this like sticky. I'm not exactly sure. Like to hold a value there until we come through again. So this now, okay, so this, yeah, okay, right. The clock is still running here. So actually what I need to do is sort of flip the way I was thinking of it, where when you now pass in, when you're not passing in next, that is your use signal. You may use the value as long as you are not trying to advance to the next thing in the iterator. That was sort of the key reason that I had built this iteration setup in the first place. What all is this even wired into, man? Yeah, that's not right. Wait a minute, is this right? Why did I wire that up to... Oh, no, that's... Okay, hold on. The stuff wired directly from here is correct. That's only what the next stuff should be. The use is the stuff coming out of the high here. So that should be going to that one, and that one. So that's all correct now, and I can delete that. So this is not confusing at all. It is now correctly reading 0 and saying that you may use the value 0. This is just wire routing for next, and then this is our done signal. I'm gonna pull in a switch to let me just manually tick us to the next thing. So this now says you are not permitted to use this index here, because we are in the sort of, we're ticking to the next stage of the iterator, and we want those to be mutually exclusive. When this is done, we are now using 1, then 2, then 3, then 4, then 5, then 6. The thing is, I don't have a maximum on this right now, so let's get another maximum in here, some value that'll be like, here's the total number of cases that you are working with. So let's say that we wanted to go up to let me try the reset. Let's say that we wanted to go up to 5. There are 5 things, so we want the index to go 0 through 4. So there we go. We reset it to 0, and we are now happily in the state of using here when we, let's see, we're not saying done, we are actually saying that you can use this value right now, which is like wrong. So that's intriguing. I think that's a bug that I need to fix. Now it ticks to done when you do that. So yeah, okay, that's a bug that I need to fix. But we're reset to 0 now, and it's actually working correctly. It says, you know, you can use the value 0, then toggle to 1, but you can't use it. It just advanced to the next. Now you can use 1, advance to 2, use 2, advance to 3, use 3, advance to 4, which is the final index, use 4, and then you hit next again. Now the whole thing ticks to done. And now it stays there, and nothing that you do will ever allow you to use those values again. This seems good. If you reset now, the sort of funky thing is that it's reset to 0, but, well, no, let's see. Then it toggles high. Okay, so toggling high again, like, kicked it into the, maybe this isn't exactly what I want now. I had to hit next one more time to actually, like, send it back around to the top state, which maybe made sense when I had the clock, but probably doesn't make sense now. Oh my god. I've literally spent 2 hours just figuring out how to iterate through a list. I just hit the 2-hour streaming, like 2 hours uptime. Because this doesn't feel right to me, right? When I'm just clicking through it manually like this, it feels like clicking reset should just always reset me without clicking next, you know? It's managing the index correctly. It's just all this state up here that I just don't really feel confident in. So what I was trying to do before was make sure that it played nice with the clock, where like if it's going to be automatically alternating high, low, high, low, high, low, where high means use the value, low means advance to the next. And you wanted that to be the thing actually driving this. Then I wanted to make sure that that really doesn't seem necessary now that I think about it. You should be able to just only send reset on the low when you're done. And then as soon as it goes high again, it would be fine. So yeah, this isn't, I don't think that this is necessary. I'm gonna scrap that little reset thinger, and we're going to rethink how it works to do this. So let's say that you tick all the way to done. So next here, now you're in the done state. This doesn't do anything anymore. This is correctly done. Now let's say that you hit reset here. And now it is in the use value 0 state, advance to next. That works perfectly. Let's say that you were already sending next at the same time that you send reset. So this still resets it fine. But then when you stop the reset, yeah, it's like click to the next thing immediately. I don't think that's actually something you'd have to worry about in practice, because in my situations, the way that it would probably work is that you send these two at the same time. Yeah, this really doesn't do anything at all until you release this, and then it's fine. So really, I think a condition of using this is that you should only send reset when you're also sending next, or you should only like, God. I feel like I think that resetting should only be done when you're not in the use state. So if you want to reset it, hello Duplex, how are you? Tell you what, I'm actually just going to hop out and see how well this works myself, just in my own case here. I'll return to my overall outer scene. Give that an update. So, oh, and I can pull the clock in as an external thing now, so that I can, if I want, drive the whole thing from the low here. Low means next. So this should now be, yeah, so this is now iterating me through this whole list. How come I don't stream on Dreams? Because it's the advent of code. Like, I had to pick whether I wanted it to be like to play more to the Dreams audience or the Advent of Code audience. Advent of Code people are probably going to be looking in software and game development, you know, if they want to watch that. So I figured, I'll stick with the software and game stuff. Although, for all I know, there's a much bigger audience over on the Dreams category. I guess I should probably check that out. Because now you've got me curious.
What you mean?
Cool. Thanks, Twitch. I think that software and game development has more viewers than Dreams, so I don't know. I'll stick with this. I do have the Dreams tag, so you know, my hope was that would kind of be enough for people to find it. Although I guess I don't show up when you search for Dreams, so whatever. Okay, hitting reset isn't working here. And why is it not working? Oh, God. I'm dumb. I'm a dummy. Time to dive back in and edit the source on that one. Boy, that sucks. I had stuff wired up to my little reset switch, but not the reset node, so it actually did nothing when I deleted my like debug switches. It's exactly what you love to see. I also like... What I feel like should happen, I guess this is where I kind of feel like I was doing the right thing to have the like selector in there for some measure of stickiness. I only want this thing to reset when this thing is low. So we're going to only go back to state A here when we are not, or when we are telling it to go to next. Only when you're in the next state can resets occur, but it'll be sticky. So I think here I gotta put my debug switches back in now. So this is my next switch, and this is my reset switch. And I need to put in my slider for total again, just like I love to do. So I can click to next, 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 next. And now we're done, and this doesn't do anything anymore. If I pulse the reset, that sets it back to index 0, but doesn't actually reset until I... Oh no, this is exactly what I didn't want. Oh, God. I'm doing Advent of Code. If you haven't heard of it, it's a yearly set of programming challenges, which you would normally do in normal programming languages. I am doing it in Dreams. So, yeah. So the problem here now is that it's skipping straight to... Because when I pulse this thing, it sets it back to index 0. When I hit this to go to the next one, which I wanted to just reset it, it does reset kind of, except that it kicked right over to index 1. So that's freaking annoying. So do I explicitly want it to be the other way? Like, I'm just sort of spitballing now, but do I want it to be only when you're in the use state? So in fact, let's just say that now I kick it over. So we're resetting. And now we are explicitly on use 0, use toggle to 1, use 1. Move to 2, use 2. Move to 3, use 3. Move to 4, use 4. Done. That keeps incrementing now. Why does it do that? Why does it do that? Why did it kick back to A? What did I do? What? What is forcing it into state A right now? This is off. It's just not going to done anymore. No, that's forcing it back to A. It's when I go back to use here. But the only thing coming into port A oh, that didn't do a reset. This isn't... Wait a minute. What? Reset. Okay. Then you can reset it, and that immediately toggled it back. Okay, that's working now. The reason that I wanted to do that, though, is say that you toggle it while you're in the next state. Now, you wanted to not drop that reset input, which is why I had this selector here to make things sticky. And then you drop back into use, and now we're in sort of the original state again. And we say use 0, toggle to 1. Use 1, toggle to 2. Use 2, toggle to 3. Use 3, toggle to 4. Use 4, done. If you fire off the reset while you're in this state, that actually still works fine. Now I want to try resetting midstream. So say that you're in the next state, but you haven't finished iteration yet, and you hit reset. So that's a little bit bad because it's still toggled immediately to 1. You can see it like resets to 0, but then when I power down, the next state is already on. So, I mean, maybe I just don't have to worry about that because like resetting midway through iteration just shouldn't happen. So yeah, you know what? I'm just gonna say, forget it. I don't care. That isn't real. Nothing is real. Let's clean up a few of these things here. I'm gonna rename this use. This is reset here. This is the signal to actually reset. Gotta run your wires all nice. All real nice like. you know? I wish the wires were easier to see on this background. They're kind of sadly difficult to read. This is beautiful, 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 beautiful wiring. Why is that? Huh. Just looks a little bit odd, but I guess that's not really a problem. It is imperative that the wiring be pretty. Absolutely critical. Being honest, I should really just leave this alone at this point and get back to the actual challenge. But this just is a welcome respite in a terrible way. So we'll call that on the iterator for now, back out to the main thing. So it clicks through to the end now, and then it's done, and then you can reset, and it'll click through again. That seems good. And now, perhaps, I can actually use this to power the rest of this. So if I want to iterate 3 times through that list, what does that look like? I think it basically just looks like me firing a few resets and stepping to next each of those times. So basically, instead of this reset switch, I'm going to have it be that when this thing goes to done, that goes to next. And when this thing goes to use for the first time, this thing is going to go to reset? Is that right? That doesn't feel quite right to me. I mean, this is certainly not working, so that's already a great start. And I suppose it's just because the use signal is hot on reset, which, yeah, that was immediately wrong, actually. It's close to right in that when we click to the next thing, you know what? Fine. Back into the source again. I thought I didn't need to expose the next thing, but since you might need to reset stuff when you toggle to the next, I am going to actually expose it. So next is now an output node, which can be used for any manner of terrible things. Go ahead and update that in the scene again. And then on next, that's what we'll pass into reset. So that'll iterate through, then next, then it'll iterate through again, then it'll iterate through again, and then it's done. Yes! God, finally! So this is great. So now I actually have like the iterators actually compose with each other. 2 hours and 22 minutes in, I can nest loops. This is great progress. Oh my God, this is so much harder than I thought it would be. Okay, so I can nest loops now. This is a great behavior to have in a program, you know, the ability to actually like iterate and then have like an outer iterator. Which means I can now do the terrible step of doing 52 outer loops to compute the pass through this string. Up to 52, I should say. 52 is the worst case. So let's do that. I'm actually going to get it to solve one of these strings, one of them, and then I get to like maybe duplicate it and make a bunch more programs or something so that it can like do the sort of meta step of summing up all of the individual rucksacks. So we've now done almost 1/6 of the example problem. Almost. Thank you. So I want to actually go up to 52. Because there are up to 52 letters. These are all the letters, by the way. So this whole list here, what that all corresponds to is what you can see down here, the V, J, R, W, P, W, T, W, J, that whole string. Each with the number for that letter encoded here. And that's what I'm iterating through. That just iterates through the string. And you can see sort of the output over here ticking through everything. Oh, and in fact, I could actually show this again. That this is the number that it is going through, and then it starts over and all that goodness. And it's doing it now 52 times, which is just what you love to see. So let's actually do the math of it now. So what I'm supposed to do is to iterate through the like first half of the string and the second half of the string kind of separately. Like the way that the problem is set up is that each of these strings represents a single rucksack and the contents therein. And the first half of the string represents compartment 1 of the rucksack. The second half of the string represents compartment 2. There is one character that the two compartments have in common. One item that can be found, one and only one, exactly one item that can be found in both compartments. In this example here, it is the item represented by lowercase p. You can see that the lowercase p occurs in the front half of the string and in the back half of the string. And that is the only letter that appears in both. Now, this can depend on the length of the string, but that's not really that hard to do. If it's always an even number, then, you know, I can still just, in my normal iteration, be like, is the index less than half the total, greater than half the total? and it's completely fine. So I guess I will start by computing that. That seems reasonable enough. You know, it took me so long to get here, but now, you know, the hope is always that what I'm building up each day will help me the next. So now I've got a better, more flexible iterator and a clock thing that I can drop in, build, you know, good building blocks. Because my goal with this whole month is to like get really good at working in dreams, push it to its absolute limit, learn to think in dreams, you know, like, and from there be able to make, you know, reasonable judgments about like, how much do I like this programming paradigm? What is it sorely missing? What do I actually, you know, what works really well that is unique? One thing that I love is being able to just like hop into these things and poke and prod, like flip switches and just sort of like step through that way, or to just preview values on the fly in the whole program. Like having all that stuff be very tangible is something that I love. On the other hand, the programs are so sprawly that like stuff that would be normally pretty straightforward for me to keep track of can just be like, I mean, they're just enormous, right? Like thinking through all the states in this iterator is like terrible. And you can't like leave inline comments either. So you're just sort of stuck with naming things, and that's about it. So in any case, if this thing is basically going to be like, well, here I actually should push these together. There's no reason for them to be so far apart. Now, if the total value, so if we're in the first half of the list versus the second half, we're going to do one of two different things. We are always acting in the context of the sort of current letter. So let me actually grab a node that I can use for, no, that's not the right thing. The index here, I guess it'll be 0 through 51, so I need to add 1 to it. That's going to be the letter that we're currently checking for. I know that this is an inefficient solution because literally what I'm doing is just iterating through the lowercase and then uppercase alphabet going, is this the letter that appears in both? No. Okay, is this the letter that appears in both? And so on. Because it seemed easier than like figuring out how to sort in dreams, because that would require me to not only make what is essentially read-only memory, but read-write memory of arbitrary size. And like, no thanks, not today. I said, no, I don't want to. So I'm going to call this node current letter. And then basically we're going to have let's see, I could use dreams global variables for this, which would be a little bit easier than doing memory cells. So I think I'll do that. This is going to be C1 letter. Or actually, this is going to be whether the given letter was present in compartment 1. So I'm going to call it in C1. This is essentially a Boolean variable. So I can make the min 0 and the max 1 just to be very clear about this. Can duplicate that to be in C2. So basically, whenever we tick to the next one, we can set both of these variables to 0. And this is where it's nice to use the built-in dreams variables because they have a separate variable modifier node, so that I can use this next signal to power these on and set these both to 0. Oh, actually, I need to. Okay, that one is referencing NC1. This one's referencing NC2. Both of these are going to set their variable to 0 when they are powered on. I guess you could also say reset. That probably is the even better operation to do. Nice and clear. So that will reset both of those, and then on each of these, basically if, oh what? My stream preview died over here. Is it still working? I'm still good. I'm still good. So basically, if the primary comparison that we're going to do is an equals, where we check if the current value, the current letter that we're iterating over, right, from our whole set, if that is equal to the current letter that we're kind of iterating over for everything, then we're going to set one of two variables. I also should probably be explicit about the use thing here. I think that I only need that for more variable modifiers. So here, let me actually just grab these two, because I'm going to be modifying these same two variables. So if they're equal, and I think I'm just going to have like a big ol' and here, where each of these is going to set, that doesn't know about the maximum for the value. It's going to set it to 1, and that should have set it on both of them. Yep. It's going to set it to 1, but I need to do the calculation for like whether we're looking at compartment 1 or 2, which is where I need to look at the current index and see if that is less than the total divided by 2. Let me make sure I'm not off by 1 in here. If there's 24 things, then that means that indexes 0 through 11 are in the first half of the string, and 12 through 23 are in the second half of the string. So I need it to be, if it's less than, say, 12, then it's compartment 1. Otherwise, it's compartment 2. So I'll throw in a not gate on that. So I'll activate one or the other of these. However, that's actually not quite the whole story, because we only want to power on one of these if this comparison was also true. So if we're looking at the right answer, then yeah. So each of these needs to be not wired in directly, but fed into an AND gate, where we check if it's equal and we're looking at the right compartment. Then we saw it in that compartment. So let's duplicate that to this as well. And then at the end of the loop here, Here, I'm going to get rid of this iterate to next thing, because when this thing goes to done, that's our cue to actually like see if both of these are equal to 1. So really, I guess we just want to check if the sum is 2. That would probably be the easiest way to do it. So if these two variables in C1 and in C2, if their sum is 2, then we found our answer and we should shut the whole thing down. How exactly do I want to sort of trigger this? Now, here to tell you what, I think I'm overthinking that slightly. So basically, if we are done and they're equal, it's another and. Then we found our answer. In that case, we want to be done, but otherwise, you know what? I just realized I could maybe... Oh, that's nice. I can do this instead of a NOT gate in a lot of situations. If we are done, then we move on. Otherwise, we iterate to the next thing and start all over. So, unfortunately, now this is just going to be so damn slow. It also didn't iterate to the next thing. So that's a great mystery. Let's see, is this working? Does this like turn off halfway through? Or I guess I'm looking at this less than. Wow, that's not working at all. What is this? Okay, so I'm definitely dumb, and this is... Yeah, I didn't wire this up correctly at all. This is supposed to be if the index is less than... Yeah, okay. Okay, so this should now be like setting in C1 versus in C2, and I think that that is working because I see this thing toggle halfway through. It clearly didn't find lowercase a in both. Well, actually, wait, why did this toggle to 1? Who did that? Who did that? Who's responsible? Couldn't be me. To be clear, this is if the current letter that we're looking at matches the current letter that we're iterating through, which for the time being is 0. Because yeah, if I like replay this, you know, you can see, wait, 0? Is this not adding 1? Damn it. Well, that's fine. That's not the bug. Should be checking if it equals 1, and then Yeah, it doesn't here, so. Oh, these wires are a tangled mess again. So it turns on neither of them. Well, okay, so that actually did work. And then we get to done here. Oh yeah, this logic is wrong. Wait, no, this is... The splitter does not help me. The splitter does not help me. Booleans aren't positive negative, they're positive 0. So if we did not get the match, then we're going to feed that into next. However, we don't want to feed into next always, all the time. So only when we only are gonna... What? I'm sorry, what? No, I didn't want that. Why is it doing that? It totally doesn't depend on that at all. It's just like when I power it down, okay, we're not going to use that as a power thing. We're just going to use another AND gate. It's freaking annoying. Iterate through. Step to the next. Iterate through. Step to the next. Now, unfortunately, I think that what I should do is put the letter lowercase c at like roughly the start and end or whatever. So instead of, I'm going to replace the lowercase p, which is 16, with lowercase c, which is 3. Which should, after 3 iterations of the loop, then activate. Okay, so it found it, and we're done. But what is current letter? Current letter is 3. Yeah, this is good. So it starts out at 1, iterates through, goes to 2, iterates through, goes to 3, iterates through, and is done. Because it found the letter C in both. We're getting there. We're getting there little by little. So that actually worked. It found the same letter in both the front and back halves. And basically decided to be done there. So this is good. This is good now. In fact, I really need to save this. Or maybe I should set the 3s back to 16s so that we don't forget and get the wrong answer in our program, you know? We'll save that. So, we now, tell you what, I need to drop another little visualizer here. And we'll play through. And when it stops, this should stop on 16. I'm going to speed it up slightly because it should work fine. $10, $11, $12, $13, $14, $15, $16. Please stop. Yes! Whew. Okay. So it found the letter P in both. You can see right down here, the priority of the item type that appears in both compartments of each rucksack is 16 for the first string. That's 1/6 of this problem done. But I mean, realistically more than that in terms of the actual problem solving process. Because now what would remain is to like sum all these together, to actually encode all the different strings and then sum them together. Which at this point, honestly, I can do. It's tedious. It'll probably take me another hour just of like inputting numbers into the program, but it works. It does work for one string. This is progress. This is progress. So let's consider now how this is going to work here. We are going to have now multiple rucksacks. We're going to, because here, I could actually change the picture on this to, nothing really rings of backpack to me, does it? Whatever, that's your rucksack. We're gonna have multiple of these now, where the sort of rucksack interface, as it were, is that it takes in the like index of the index that you want to view, and it returns the total number, that like the total length and the value. That's it. So not too bad. We'll duplicate this one up here for now, and I basically want to make like 2 of these. So the next one has, let's see now, I need to actually hop back over and grab the second string. I have a little Lua program which also runs hilariously slowly. It's because I use this tool, this little Lua REPL for education. So it's got a bunch of hooks to like print stuff out, and it runs really slow as a result. It may be deliberately slow, to be honest. But anyway, here are the numbers that we're going to be importing. So let's grab those and get them on stream for everybody. Okay, these are my new numbers, and it's length 32. So now we get the enviable task of extending this to have even more things. And let's start perhaps by bumping that up to read 32. And if we have 24 right now, then, I mean, we're just adding 8 more, so that's unfortunately going to require me to flow to another selector. We'll push that up to 10. Copy all this down. And this is only going to have 2, because, 32. Wire this up to this. Change some numbers. This becomes 30. This becomes 40. Yeah, actually that works fine. This becomes 30. But other than that, it's fine, it's easy, it's good. Oh my god, I changed the wrong things. It's fine. It's fine. There we go. And now we get to keep duplicating all these out. So I need 6 more on this one. Which I have to manually wire up the power for, of course. God, that's really annoying. That, like, I have to be really careful about the one that I'm, like, where I position the cursor when I pop one of these open to go to the power. Otherwise, it just, like, gloms onto the node behind it for some bizarre reason. This, my friends, is how you do strings in Dreams, as far as I know. It's a thrilling, thrilling, thrilling process. And we only need 2 more down here. So that's merciful. And then I just need to go through this entire list and set all of these numbers. Oh, no, I'm not even done. Because I have to wire these all into this. You love to see it. You just love to see it. Okay, and now I actually get to go through and manually set all of these to the correct number. Oh, okay. So, 10, 17, 34, 44, 40, 17, 44, 10, 17, 26, 10, 33, 30, no, 33, 30, 38, 33, 38, 18, 19, 32, 39, 6. If I end up off by 1 at the end, I'm going to be so sad. 32, 52, 45, 18, 38, 18, 32, 52. Yeah, we're good. 32, 52, 19, 45, and 38. There's just one more string. That actually, I mean, that doesn't take like the longest ever. That's mostly okay, right? If I patch that here, let me make my meta microchip where I can put all the other microchips. This one's called Rucksacks. And this is going to itself have a like 6-way selector on it. I guess we'll start with just 2. So that can power on one of these at a time. We can start it on port 2 at the start of the program, though, somehow. And this then is going to have the current index and the output total. It's essentially just going to sort of proxy the ports from over here. So we'll grab those and bring them over here. So the current, the total, you know, these are all like the values of the current rucksack. And this gets patched into all of these. To start the program off, I guess I'll just drop in a switch that's going into port B, so that right when you start, you're on this one, which is then going to ensure that we are iterating through this. I mean, is this working? No. No, not at all. Well, okay, to be fair, it's not wired up to anything, so like, surprise, surprise. Let's patch this in exactly the same place, exactly the same way. The ports all go to the same ports. This wiring is not confusing. There we go. And now, if I pop open this other program here, that is now the thing that we're iterating over. And it seems like it's working great, so. This is good. This is good. So I can now sort of dynamically wait, why did it turn off? Oh, did it find it? Why did it stomp on 10? Is there a single 10 in this list? There's 2 10s, but they occur. There's a few 10s, but they all occur in the first section, not in the back half. So what gives? What gives? I mean, it's now 0, but the total would absolutely come in here. And so when we reset it, we get 16. And then we do whether the current index that we're looking at is less than 16 to determine if we're in compartment 1 or 2. What? Like what? Like what's it doing on 10? I don't understand. What's it doing on 10? What is it doing on 10? To be clear, is there one? There is one right at the boundary. So I think that I am in fact doing it off by 1. Or no. Let's see. 10 is A B C D E F G H I J. Yeah, I mean I could have told you that the 10 is the first one. There definitely, from looking at the string down here, there don't seem to be any J's in the back half of the string. So I'm not really sure where this 1 is coming from down here. How are you getting there? That would be coming from here, which, like, how would you do that? 3, 4, 5, 6, 7. So it found a 6. 8, 9, 10. Oh, they both bumped up. What? They both bumped up to 1 like immediately. Also, why did it increase? There's no like, oh, I guess A, B, C, D, E, F, 6. I saw it trigger on 6, and I guess that's because there's a lowercase f in the back half of the string. So when this thing hits 6, let's watch to see if in C2 trips. It did. So I think that's completely expected. However, when we then wrap to 10, no, next run through. My hunch is that because the index is 0, my logic is somehow wrong. When my logic is, because we've got this 10 right here. It's at index 0. And it just feels like there's got to be something, whoa, something related to that, like, why would it be the only thing that breaks, right? So, the value coming out, this would be 0 if the node is powered off. So maybe that's the issue here. But on the other hand, oh, this isn't being wired to anything anymore because I'm a freaking idiot. Shoot. What was this wired into before? I feel like it could be wired into this, where you're only allowed to make this comparison if we're actually looking at a value, like a valid value from this thing, because this is the comparison that drives the rest of it, right? This is the thing that then determines, yeah, so let's, it's flickery and gross, but it might still work okay. On 6, we should see this toggle up to 1 still. And it does. Now on 7, 8, and then 9, we should see it. So 10, okay, I feel like there's still a bug. I feel like there's still a bug. I feel like it toggled too late. So let's run it again. And when we get to 10, I'm gonna try to stop it like right away when it's up at the top. Like right after it sees that first one. So 6, 7, 8, 9. Now I'm pausing, but I wanna just like, yeah, didn't work. Didn't work. So the current letter that we're looking at is 10. We already moved past this, which means that we should have registered as seeing value 10 in this bucket. We didn't. So that sucks. And why would that be? Is it because, I mean, the use thing here, tell you what we'll do now. We'll run it again, but I'm gonna slow it way down once it's near the end of the list, because I have the ability to just slow down execution to a crawl whenever I feel like it. So let's get up to toward the end of 9 again. Here we are on 9. I'm going to pause it. I'm going to slow it way down. And where do we actually want to stop execution of this? I think I want to do it like, I mean, basically as soon as we activate up there. So we're going to tick around. Okay, so now everything powered down. That's fine. We're about to reactivate up top, and there we go. So now, oh my god, it did trigger. Is it iterating too fast? Oh no, 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 no. That's not what I wanted to see. My logic works, but there's like, it's ticking too fast. I have to slow everything down just to get the correct result. Let's try it again from the top, but with a slightly slower speed. It's going to take longer to get up to 10, but 5, 6. Oh my god, it skipped 6. Oh my god, what? 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 I mean, you're joking. You're just absolutely joking. How can it be doing that? How is it triggering the reset twice? Okay. So, I think that my problem is let's try that. Okay, I think that did it. So it was like a weird clock sync issue where both this iterator was like running while this iterator was iterating, and like there was some terrible race there. So now this iterator is only allowed to run while this iterator is in its used state, which is really where it should have been before anyway. So now this is seemingly working fine. And when we get to 10, what's going to happen? Are we going to immediately bump up to 1? We are not. We are not. Damn it. Why? Why doesn't it? Again, let's just iterate through. Oh my god, why? Why? What is this now? What was any of that? Huh? I've paused time and it's doing this. Apologies for the flickering. I hope neither of the two people watching me has photosensitive epilepsy, because I have to figure out this stupid flicker bug. So time's paused, which means that, let's see, the issue here is that, so if this is powering on and off, so this is the thing that now is somehow, it's this iterator is somehow stuck in a state where, or no, I guess it's not really, it's that iterator is happening because of this. So there's like some kind of terrible cycle here. Let's get rid of that. I feel like the issue with that is that it's like shutting off the done signal, which is not actually what I intended for it to do. But I still need to fix the issue where when this thing gets to the end of the list, it starts a whole flicker fest, or it. So that's doing the double click now, where because of sort of desync between the iterators, it's like accidentally like sending one to the next. Whew, which is bad. It's all bad. What I really want is to sort of reset the clock when this thing first clicks over to use, because I think that's kind of the crux of it, is like these things can get out of sync where this thing like sort of powers on, it like resets while it's in its next state, and that's how it skips one. I mean, I've seen that happening before. So the issue is that I somehow need to like reset this clock. And as far as I don't know how to reset a signal generator. That like I could not find a way to do it before. Because if you mess with the phase offset, then it like, because that is actually what is like changing over time while the signal generator runs. So you can't mess with that, which honestly is kind of a useless behavior. Like, what is the point of having that wired in? I just don't really get it. I want to start the clock over, you know? I mean, ideally it would be like every time this thing gains power, but the problem is, if I like, let me just grab another signal generator to play with it. So this is our signal generator, say, and this thing is just oscillating like so. If I turn it off, it just pauses there, and then when you power it on, it continues again. If anything is wired into this phase offset port, then you can like sweep it through the phase, but you know, once it's wired, it just sits there. So like, that's no good. And as soon as it's detached, now it actually runs through time, which is the thing that you actually wanted it to do. So is there any reasonable way to actually, like, could I use a separate timer whose value I can poke? The problem is that I don't have the ability to poke a timer either. Like, I can, because timers have the same behavior, right? Like, I can set the current time, but then I power it down, and then I power it on, and it like, and I can, I guess the advantage here is that you do have the ability to reset a timer, so I could kick it back to the start of its phase. So what if I did this, and then I wire the timer output into phase offset as a modulate. Oh, I think that okay, timer output is, what is the literal numeric value of timer output? Yeah, it's 0 to 1, as I expected. So confusingly then, I don't understand what I'm seeing with phase offset at all. Like, it seems like it should just sweep smoothly from 0 to 100, but it like totally does not. Like, what is it doing here? Right? Like, what is it doing? If I multiply this by 2, and pass that in to modulate instead, I do need to wire it up to this. It just peaks there, but like, this is like by no means a steady, there's like an awkward pause. What is that? Like what is that? It doesn't make any sense. God, if I'm doing it with a timer, then there's no reason to have the signal generator at all. I might as well just ditch it entirely. I think that I have to build my own, like a resettable pulsar which is just what I want. If I hook this up, if I set the target time, so I can hook it up so that whenever the timer finishes, it resets itself, which, you know, means that, oh, 3.5 seconds and then it resets. That's cool. What if I do like, you know, 0.1 seconds? Oh my god, I love this so much. I mean, it's incomprehensible now, but it does probably end up pulsing the done thing quite a lot. The thing is that it's not even exactly what I want. Because I guess now what I can do is like do if this is greater than or equal to 0.5, because that's like the 50% mark, you know? And here, let me hook that up to another node so they can see it blink. So this is our sort of signal now, and now I could actually sort of reset the timer whenever I want, right? Like if I have this on a 1 second, 1 hertz thing, then it's like, oh, actually I want to flip this to less than so that it starts high. High, low, high, low, high, low. But then I can reset it whenever I want. By piping into here. It's a little fiddly because if it's active, then it like, yeah, okay, so in practice, what I would probably want is an internal signal manipulator that turns that into a pulse, which is fine. That's all good. Right, like I can just reset this whenever I want now. Okay, guess I'll replace my signal manipulator with this. I'm so annoyed, but it's whatever. We're gonna call this thing pulsar. Or no, we're gonna call this, I guess, like, well, how is this different actually from the like clock thing that I had before? Kind of isn't. I guess I just want to replace the internal implementation of clock. So, I guess I'll just dive in and edit the source on that. So, no more signal generators. Signal generators are bad. They are no good, very bad, etc. I want the, let's see, what is the default? I wanna wire in something here and say that this is like, say this is back to a 1 second default. It's 1 second, so the total period is actually 2 times this, which is why I guess I want the default value for the timer to be like 0.2 if I want it to be sort of ticking at the same rate as the other one. Drop in our calculator again. So if this is less than 0.5, then it'll be the high signal, which is what I want. when it is finished, it will reset itself. You know, if you were to hook that up to our output node here, it is ticking like you'd hope. The timescale here can just come in to multiply this, where it's gonna default, I guess, to like as fast as possible, which I think is reasonable. And so this I actually want it to be min value of 1. Then you can slow it down. So like, you know, 3 times is like, well, I guess all the way up to 5 would be like a 1 second period on the whole thing. 1, 2, 1, 2, 1, 2, 1, 2, etc. So if you're all the way down at 1, okay, adjusting the time scale midstream can cause it to not actually trigger the timer fired thing, but that's not really a huge issue in practice. So this is like the fastest pulse you get by default. But then you can, actually I could maybe make it faster by default. Yeah, okay. And then you can slow it down with values greater than 1. Okay. Oh, I need the reset button. That's like most of the reason that I came in here, was that I wanted a reset. Okay. So now you can pulse reset whenever you want. And actually, now I'm curious. I want to test how resetting works while the timer is powered down, because I feel like actually that should work okay. So it's powered down. Let's reset it. It doesn't reset. Okay. The signal generator was a lot more reliable at just staying on, you know? You know? You know? Because I can't even, like... It's no good if it's just gonna pause. But the issue here, the issue is that... I reset it, and like the signal to that reset port just stays on. But while it's on, it won't. What if I hook both of these up to a signal generator or a signal manipulator? This is why I wanted to use the generator, but if the generator doesn't do what I want it to do, like, what do I do? I'm sorry, why are you not resetting? This is reset timer. God. Well, I guess this really doesn't need to be. Okay. That's so annoying. that's really very incredibly annoying. But I think this is broadly working. I can reset it partway through. It'll keep cycling around high, low, high, low, high, low. I really do wish, though, that I could reset it while powered down, but I don't think that'll actually matter. I shouldn't ever have to power the timer down. So let's leave it at that and return to the previous creation. And with that, we should be able to actually reset this timer when we move to... I guess we could do it when we move to next, but I kind of feel like I want to do it when we move to use, because that'll be a pulse in on that. Yeah, I think that did it. Because now it's not skipping anymore, and it was skipping before. And you can see that whenever we take over to the next one, that one's firing for a tick. It's still pulsing plenty fast, and I can slow it down if I want. Speed it up slightly to get to the end of the 9. And now let's slow it way down. Okay, it actually did read the 1 there at the start of 10 this time. So now what happens if I just kind of run the whole thing at top speed from the start? again, we should see this tick up to 1 when we're on 6. So 6 should be coming up here. So we're on 6, which means that this should now tick up to 1 late in the process, and it does. Now 7, 8, 9 should go by without anything. And then on 10, we should see this tick up to 1 immediately. Oh, it did. So maybe that synchronization thing fixed it too. That wouldn't surprise me. That seems like a likely place for a bug to lurk. So if we let this run, which I mean takes a hilariously long time, I love it, then it should land on. It should move to the next one on 38, or it should stop everything actually when it does 38. '21, 22, 23. I knew this was going to be slow, but I'll take an inefficient solution at this point. If it's taking me this long just to do basic iteration and work out all the kinks in that, imagine if I was also trying to like sort lists or do anything crazy like that. I mean, it would just never happen. So these are the values that we're seeing. So it saw 30, but not in both. We're coming up on 38. Saw 33, but saw 34, but no. $37, and here we go. Should find 38. Found one, on the other. Yes! Yes! Yes, 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 finally. Okay, we have successfully done the second string as well. And if I start the whole thing over and let it run again on the first output, this should now stop on 16. And it's probably not going to find anything, or no, it finds 6, but that's the only one. That's right. Because 16 is the letter P. One, done. Yes, 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 yes. I can actually do this now. I can actually do this now. We're going to save this. And now what we can do is we can sequence these two together so that when we can actually throw an iterator on this thing, which I love it. I love it so much. Will allow me to step through all of the available all the available programs here. So we're actually looping through all the rucksacks in addition to looping through the string and the overall characters. So let's kinda let's see. I'm gonna need another iterator. obviously. I need to make a note up here that's like num rucksacks, so I can collapse this one. This doesn't need to be open anymore. Which is actually just going to be pulled from this thing. The number of the selector. I hope that'll work. I had to do, oh, that was just because some of the selectors were powered down, but not, okay. So even if this thing itself is powered down, yeah, whatever. That is going to feed back into this iterator's total. This iterator's next is going to come from this whole thing, because when we actually find, here, I'm going to add another node down here that's just like found item. It's the closest thing to a comment I can get. So if that's false, then, and we're at the end of iteration, then we're going to loop to that. But then otherwise, if we find that wire is like totally invisible. If we find it, then that means that we move to the next rucksack. There is no reset on this. We're never going to reset this. We are going to reset this. So when this goes to the next one, we actually want to reset that iterator. We'll figure out the end condition later. The index of this wires into here to be the current port. So I guess that'll be current rucksack. I'll give it a nice name. Names are nice. What's scary is that I feel like everything needs to shut down when this thing, I don't know. Because if I think through all these conditions here, when one of these finishes, it's going to kick over to the next. It's going to reset this iterator so that it starts back at letter A. But over here, what did I have to do to control? Maybe it's fine. Who knows, you know? Maybe it's fine, you know? Who knows? Because this use thing was used only down here. This use thing could be used to power on that iterator, but I don't think it has to. I'm going to speed up evaluation of these two by doing another modification to this. So I'm going to replace in the first word the numbers, the number 16, P, with 4. So lowercase d. And in the second one, I'm going to replace uppercase L with, what's another one that's not present? There's no lowercase e in that. So I'll replace that with 5. So 38 gets replaced with 5. This will just dramatically speed up evaluation and allow me to test if the end conditions work. So let's go ahead and run this. So it's ticking through the first one now. Three, 4, and this is the one that it should find. That's interesting. It ticked to next, but because we never, it's stuck on next basically, which is not what we want. I guess I could just pulse it. Is that the thing to do? So when we find an item, we could just pulse next, which would, I suppose, kick everything to the next, because this is also stuck in reset mode right now. And as a result, this thing is still just done. It hasn't been reset yet. This all actually seems fine, but okay, now is it iterating over the next one? No, why isn't it iterating over the next one yet? This one reset. The clock is pulsing. This thing is still done. It didn't receive the reset signal? I guess it wouldn't, would it? Okay, sure. Just keep the random resets coming. At this point, I'm doing that thing where I'm sort of firing blind because it's just like, yeah, that feels about right. You know, like, surely it's so close to working that I don't actually need to understand it. I just need to, like, try something and it'll probably work. I mean, that's definitely true. So on 4 here, it should find it, and it should move on to the next. Everything's been reset now, and it's moved on to the next one, and it should stop at 5, because everything should trip to done. It didn't. It stopped at 1. I think because the variables never got reset, which actually makes perfect sense. Where was the thing that reset them to? This is spectacular, man. These should reset on this too. Sure, just keep it coming, you know? Keep it coming. Four, 1, and then 1, and then it should all move on. So now it's 0, 0 again, so it should tick up to 5. Four, 5, and then it'll probably tick over to the next. No, it ticked because it tick to done. This iterator went to done, exactly how you would hope. So that's good. That's good. That's the program working. What I need to do is make a variable for the actual overall answer. So this is, I'll just call it answer. And then down here, when we find an item, we will use a variable modifier to add a certain amount to answer. That amount will be the current letter. So now when we run this, we should see this thing after it gets through 4. It should tick up to 4, and then it should go through again, and then it should tick up to 9. Okay, that did tick up to 4. Three, 4, 5, and once it's through 5, this should tick up to 9, and it should be done. Good. What now? I can input the remaining ones, I guess. Oh, I really don't need any of this down here, do I? This is all disconnected from everything else, so that's something I can remove. I'm sort of curious if I can run it faster. No, it is fritzing out now. Or is it? Ticking through 1, then 2, then 3, then 4. Yeah, it accidentally skipped 1. Man, there's so many subtle timing bugs. It's my favorite. And this froze the timer now. I might still be able to get away with slightly faster. Not that this is really meaningfully faster. 1, 2, yeah, I mean, it's working. I'll stick with it. 20% speed up. Okay. Save again. And so, it is now time to encode more strings. But I've already encoded the longest one, so it should actually go a little bit more quickly. So let me grab this again, run it through my program again. So this one's length 18, and these are the numbers corresponding to those letters. Drop that in. We'll copy over one of yonder rucksacks. We'll hook it up over here. Power it on. We'll hook up the... You know what, I'm gonna move this down here just because it's clearer that way. And this, I can actually just chop from, which is nice. Because the total on this thing is, it is length 18. Which means that I don't need this lower selector or any of the lower 4. And in fact, I don't need 2 of these. That should bring me to 18. Simple as that. And now, I just have to go through and enter all the numbers again. So, 42, 13. 13, 4. How I got a 20% speed up on advent of code by changing one value. Give me all the Hacker News points. Give me all the Substack likes. All the Medium claps. $42, 18, 48, 22. $42, 23. $23, 46. $49, 28. $23, 7. I'm actually going to put in one of them switches again, just to see if I correctly get. I mean, it's oh god, do I really have to wait for 42 on this one? But sure, why not? You know. Oh no, actually, this didn't work at all. So we'll just ditch that. I'm just gonna go for it. You know, Hail Mary. We're gonna jump all the way to all 6. Boy, that wouldn't have worked anyway because I forgot to wire these up. That's really great. I really, really do have to wire these all correctly for this to work. Next string. Length 30. Coming right up. It's hilariously slow. Printing is apparently the problem. All right, let's go on this one. Clean 30. which means, again, that I can actually delete this one down here, which I like. I like deleting. Don't have to touch anything else. So let's punch in the numbers. Well, I have to enter the puzzle input. I'm not doing the actual puzzle input. I simply cannot. It's already taking me an hour to input the example. So my goal with these is to build the example, and that's it. I really don't think that a system like this could even really process the full things in a reasonable amount of time. Especially, like, given that, like you're seeing here, I don't have iteration except by like ticking like major parts of like building out like every individual element and wiring it together in a way I can terribly iterate through. It's not built for doing the real thing. But that's not really what I care about. I just care about building programs that work in Dreams and learning how to get better at programming in Dreams to like stretch it as far as it can go. So 23, 39. 17, 22. Don't let me forget, I need to go back and change the earlier inputs that I had modified to D and E. 38, 39. 52, 34. 834. 3922. Yeah, I looked at the actual inputs and was like, oh lord. That is so much bigger than I can handle. 2338. 3410. 222. 310. 1414. 4528. 1422. 4643. And 3214. Thank goodness I'm not messing these up. Does Dream support network communication? Yeah, I'm not actually sure these days. It's a good question. So, I mean, in terms of loading files, no. The only thing that it would have is like multiplayer, like sending game state to other clients. But I think it only does local multiplayer anyway. So, yeah. Let me save this while I'm thinking of it. And then let's set up for the next Rucksack. So this one's got to be wired in here, and here, and here, and here. And let's go grab the string for that. Length 16, mercifully short. It's only 16. That means that I can drop 2 more off of this one. And change this. Oh, did I change? I did. I did, right? That says 30. That's 30. Okay, good. I wanted to make sure that I didn't forget the count. All right, 16 on this one. What's the target audience of Dreams? It looks advanced compared to Scratch. The target audience is people making, I mean, it's really for anybody to make games. I am really, really doing stuff they never intended you to do. The whole, like, like everything that you're seeing here is like unintended use of it, because what it's actually intended to do is, like, when you step on a button, then something will happen, and, you know, like, there's no need for like execution flow in the like programming system, because all execution is sort of determined by the actions you're performing in the game, right? It's like, when this happens, play this animation, and when it finishes, do this other thing, right? You're always sort of bouncing back and forth between like a little bit of logic to like kick off another action, and then something happens in the game world that takes time, and then something else might happen in back and forth, right? So what I'm doing is not like that, and it ends up making everything really complicated. You know, most of the time these selector things wouldn't be used to iterate through a list. They would be used to be like, to say, you know, activate like one of a few different modes for your character, right? Where you can be in like shooting mode, where you activate like the shooting logic, or in like spectator mode, where you're just like flying around, right? And you can just use that to like toggle chunks of logic on and off, and they're all just designed to work more continuously. Yeah. It is really amazing, actually, to go look at some like real deal games in Dreams and see like, oh wow, this is actually really robust. And actually, now that I think about it, there might be online multiplayer. In fact, I'm almost certain that there is. So I don't know. Or okay, so 2020. 736. 2044. 3336. 43.3. 2046. 52.20. And 52.46. One more. And it is slightly longer. Let's do one more run of the old string to chars script. So this one has 24 again. So that means that down here, we can just chop 6 things off of this. Okay. One more, just this one. So 29, 18. 52, 19. 36, 19. 42, 42. 52, 19. 33, 26. 23, 23. 1938. 2338. 1316. 2339. 3023. Well, here comes the real question. How are we gonna, is it gonna work? We should get at the end of this 157. If I just start it running now, this should all tick through, all 6 of them, and leave us at the end with that top left number at 157. It's gonna take a while. No, I didn't. Okay, no. I remember what I said about about going back to edit this one, because I turned 16 into 4. This is wrong, and it should go back to 16. And then similarly here, 38 became 5. Both there and at the end. Okay. Okay, now the data is actually right. So now if we just run it for probably like 10 minutes, we'll get there, you know? It'll be great. Thankfully, most of these don't have to go through all 52 possible numbers, right? It like bails early. So we're waiting for, in each case, and let's see, I guess I can just do this. So we're looking for this thing right here. That should tick up to 16, and then this should bump up by 16. And then it should go up to 38, and then this will bump up by 38, and then this will go to 42, and then this will bump up by 42. So far so good on how it's operating. So 16, once it gets through that, damn it. Why didn't that work? Oh, that's demoralizing. It just kept going. Why did it keep going? I feel like there's another like terrible off by 1 kind of issue here where like it's trying to go to the next value. Here, when this thing hits 16, we'll see if we get a flicker on this node on the next go around. We didn't. Start over. I'm gonna watch this like a hawk when this is at 16. God damn it. So close. $14, $15, and here we go on 16. So what I'm expecting to see is that relatively early this thing will tick over because lowercase p comes at slot 5. And then at the very end, yeah, it didn't. It didn't. Let's go back. Let's put this at like 2. 16 becomes 2. So we can very quickly see. Yeah, it's just no longer working. So interestingly, it did tick this up, but then so I've paused it right when it should be seeing. What state is this in? It's currently trying to go next. But it didn't. Oh. Okay, well, I'm definitely not going to be able to, like. Here. I restarted the whole thing. Oh my goodness, please. So what seems to be happening here so it's in use mode on this now. So this is where I wanted to pause it. It now has set this. And it means that when we so this thing is now registering true. We found the thing, but this has to be hooked up to done. And this iterator is never becoming done, is it? Well, it does become done. And when that occurs, these have already reset. Okay. It's actually it's extremely close to working. The issue is simply that this thing is being triggered to go to the next thing because this is done. Hey Madman, how you doing? So the thing is, it calculated the right values, but what happened is because I have this whole thing wired up now to like reset and go to the next thing, it actually reset these back to 0, which means that like on the same tick that I wanted to actually set this and save the answer, I reset both variables back to 0. So I think if I just delay this signal or change how this signal works, then I'll be fine. So if we found the item, here, let me rename this found item. That's really what this is, and I don't really need the additional. I don't really need this. No, but wait. No, but wait. How did... Oh no, there must have been another tick in the middle. I'm doing great, Madman. I've been going for 4.5 hours on this problem, and I'm inches away from it working. But I've just got a race condition now on when I reset this variable, which is fun. So what must have happened here is that this thing must have ticked to done. This thing would have been... Oh. So this thing did activate right away because at the time that the tick occurred, this was still false because we weren't in the done state. So this was all activating. So as soon as we hit the done state, well, it would have propagated forward from this, right? So this would have been done, and these would have been equal, and I wonder if it's just because maddening. It's just maddening. Because this powers on when we found the item, which is already dependent on this thing being done. Something about this is just wrong. That's just wrong. I feel like doing the ultimate hack and just throwing a timer on it. Wait, where was this hooked up to before? Oh, that iterator, that's right. I feel like that's gonna do some just horrific stuff with the like transition to the next one somehow. Start over, run again. Once it gets through 2, that's bad. Yeah, so to be clear, it's starting at 1, as it should. You never played Dreams but found it interesting, might get into it. Yeah, I recommend it. It's really cool. Okay, but this is still doing something wrong, which is not surprising to me because of this frickin' timer that I was like, yeah, I knew this was a bad idea. Because now when it like tries to go to the next, because it like finishes that off and goes to the next one, but immediately like this thing rolls it forward to index 2 before you actually want it to. Yep, that was a mistake. Just a mistake. Just don't do that. But what do you do? The number is right there. It's just inches away from working, man. Like, come on. Inches away, because this thing, like, on the final tick is just like... Oh. I slowed it way down again. Whoops. So like, and it's just not gonna tick that. It like, this all stayed false. And it just never powered that on to set it. Oh, it's so maddening. Because I suppose it's because when it ticks, when this thing ticks to next, use is going to power off and it's going to tick to done, and then done should be the thing that's powering this on to set it. But somehow it's just always this one firing. Or is it even? Like, yeah. I'm trying to get it to correctly like add up the results at the end of iteration here when it reaches the end of this. But I'm trying to like slow it down enough to debug. So we're in the use state right now, at which point we've computed that this is correct. We're about to tick to the done state. Now we're in the done state, except that we totally missed the done state. It like flickered once and then we reset because that just immediately passed through here and took us to next. No, wait a minute. What is happening? What is happening? Oh, God. Please. Okay, now take real slow through these last ones. So we're in the use phase. How did that click to... I don't understand anything that I'm seeing here. I gotta run it back again. Oh, because high means next. I'm stupid. Yep. Okay, so now we're using it, but now on the next phase, like, we're immediately... Yeah, we hit done, as we would expect when we hit next that time, but we just didn't trip this for reasons that are still not clear to me. There's just an evaluation order thing. There's just an evaluation order thing where somehow... I just don't understand how it's possible. Clearly the thing that's happening here is that this thing pulsed to get to next, which sends the next out to these and resets the variables, right? Like if I didn't reset the variables, then we'd be fine. Why is that? Huh. Interesting auto mod. Sorry about that. Thanks for dropping by and hanging out. Appreciate it. But what's baffling to me here is that this thing becomes done. At the same time, these things should be equaling 2, which means that this should be true, which should pass down this path and power this on. But that's not what's happening. Instead, somehow, it's like the done case is evaluated before this is evaluated. Or like this is evaluated first because it's like, okay, you become done. And then the not, this whole thing trips the reset, at which point those two zero out, at which point this path doesn't run. It's like, that's like what's happening here, which is terrible. It's terrible. That's not what you want. So, let's see, where is this found item wired to? This sort of feels right to me in that, like, I wonder if I could do something like the following. If I drop the whole thing on a microchip, and this microchip can only be powered when the whole thing is done. And then this is what actually checks, like, because then I wouldn't need any of these. It would just be like, we have a node on here that represents whether they're equal. I mean, this is like totally unnecessary, isn't it? But then I guess it would just be like, if that's the case, then that's where we do this variable modifier. And only if we come in here and power this up at all. And let's see, I guess I have to wire this into the variable modifier. And then it's all just depending on that. That's like, if we found it, then here, I'll make a couple nodes like found and not found or something. Pull this in here. Okay, that's all good. If we found the thing, then that's where we would follow wherever this wire is going. If it's not found, then that's wherever this wire is going. And then I can just delete these. How well does this work? It works! It works! I did it! I did it! It advanced to the next one, and it counted it. I think. Yep, it's iterating through 1, then 2. Oh my goodness. Let's put these back to 16, where they belong, and let's give it a run. So, as we run this now, and I'm going to actually speed it up a fair amount. It should stop at 16, move on to the next thing. And add 16 to this up in the upper left. It added 16. We're on 2 already, that's a bug. But it will probably work fine. So I'm not gonna stress about it. There would be a bug that, I mean, that would probably, it's slightly cheating because if the letter A was in common between the two, then it would cause problems. But yeah, speed ups like crazy, man, all over the place. Super speedy, super efficient. This is like an n cubed solution to this thing. Technically not, I guess. 52 times what? What is the time complexity of this? We're looping over the whole string 52. I guess it's technically linear, isn't it? No. Yeah. We're looping over the whole string 52 times tops. That's our worst case. So it's 52n per string times 6. So it's just a really bad linear solution, you know, right? Anyway, when this hits 38, we should bump up to 54 up in the upper left. If this is working at all. Come on, come on, come on, come on, come on. Yes! Come on, please. Please, I'm begging you, get the right answer at the end of all this. Now we have to wait for 42. Oh, it's so stressful. Imagine how long this would take if I was running the actual puzzle input. I mean, I would have to leave it running overnight. $33, $34, $35. Waiting for 42, and I guess there we expect it to go up to 96. It did! Okay, 22 next. So that'll take us to 118. I've not been drinking. I've not been hydrating. Too focused. Let's go. 20, 21, 22, and then we should see it go to 118. Thank goodness. Confidence building. Who knows what it's going to do at the end? I mean, I hope the end logic works. I sort of tested that. Got to get up to 20 with this one. Which should just bring us to 138. Yep, 138. I am seeing it reliably skip the first index. So that's a bug, and it would almost certainly cause me to fail the real puzzle input. Because surely somewhere in there, there's a rucksack whose value is, whose common item is lowercase a. 19 with this, we expect to get to 157. Yes! It's done! I got the answer. The program stopped. There it is. 157. 4 hours and 45 minutes later. Oh my goodness. That's insane. Oh man. Finally. That was so hard. Oh my god. Day 3 done. Oh my goodness. So okay. Let me step back. Let me think about what did I actually like learn about working in dreams here today. So, first of all, I would say I yet again reinforced for myself that relying on timers is a bad idea, and you should rely on like sending signals between different parts of your code. And don't rely on like timing to ever work, basically. I've written many things in dreams before where I was like, I'll just have this run on pulses on like a clock and it'll work fine. That never works. It never works right. There's always bugs. I still have a bug in this. All the best stuff works like a state machine that you can verify, where you can like, use switches to like poke and prod different parts of it and see it go like state by state and make sure that all those transitions are good. And if everything in your code is like a nice little state machine on its own, then you can actually compose that in ways that work. You can't compose things that rely on time in dreams. You can only compose things that are like a good state machine in isolation. So that's one thing that I think I kind of already knew, but that was reinforced. Another thing here is that this bug I was having at the end, dreams, I've had problems with this before, and I'm not exactly sure that I have any like solid learning synthesized from this yet, but I've had issues before where something was essentially like, there are cycles in the graph, right, where like you can follow the wires in a whole circle, and they're broken up by nodes at different places, but ultimately it is cyclical. And dreams, I wish, I don't know, I should like ask someone from Media Molecule somehow, find someone to harass. There's somebody in the Handmade Network who might know. But like, I think that the way that dreams actually executes this per tick is it must like try to, topologically sort things, but if there's a cycle, it can't do that, and it just has to break the cycle somewhere. The behavior I was seeing at the end, where it was like resetting the value before the preconditions should have been met to reset the value, like that must have happened because it had to break cycles somewhere. It chose a bad spot to break the cycle, and I got screwed by it. Essentially, all I did was to like fix this was to put a tiny bit of the logic into a microchip that I could power on or off, which must be like microchips, maybe they act as cycle boundaries. I kind of don't think that they do though. Power evaluation might be the cycle boundary. Right? Because the issue that I was seeing was essentially that it was like one of these branches. I essentially have like two branches in here. It's like either you didn't find the item or you did find the item. And like the didn't find the item logic was running before its sibling as I conceive of it. And I suspect that this happens because of cycle breaking, because they were both powered on part of the graph at the same time. What I was able to do is make it all power on, like both of those paths power on at the same time, which ensures that they always like spawn, like they always have the same input data, then there won't be one evaluating before the other. Like it has to break the sort there. So that the fact that this fixed it means that I think it was just like some weird topo sort shenanigans. As for like what this means, I probably should be trying to like condense things into microchips a little more frequently. And in fact, the big tell for me on this one was, I feel like whenever I'm doing this, whenever I'm like, this and this, make sure that you only do this when this other signal is active. I feel like that's actually often better done with power and a microchip. Like, if you want to sort of just conditionally run a certain piece of code, put all that code in a microchip and power that microchip on and off. Because first of all, it's conceptually cleaner in some ways than what I was doing before, where I had like two different parts of the logic where I was like, oh, don't do this unless you're in the done state, which is much more easily done by putting it in a boundary and turning it on when you're in the done state. But I think beyond just being nicer to organize, it probably does avoid confusing cycle problems, because you're explicitly being like, this is now part of the graph in a way it wasn't before. So I might just try to keep that in mind and do cycles better. Let me catch up on chat now. I wanted to like get all that out of my head. It took you 2 hours to solve one of the puzzles in a much higher level language. The 4.75 isn't too bad. Well, thank you. I actually kind of want to try and solve this in a higher level language now. Like, just see if I could bang it out quick. Essentially just replicate my algorithm in a higher level language. And by higher level language, I mean like JavaScript, probably, because it would just be easy to like smash it in there. Does it require to break cycles? Is it not possible that it continues executing in the same loop infinitely if there is a cycle until there's an input change, such as the clock firing? I don't think so. I've seen nothing in my time with Dreams to indicate that it ever like continues execution. I feel like per tick, it's propagating data through the graph and enabling and disabling nodes and like flowing, the whole way along. And I think that different nodes must like break cycles in different ways. Like, see, I really wish I knew. I really wish I knew. Yeah, you know what? Let's do it. Let's try to do this in JS and just see what happens. Let me get a setup here. I need to like set up my OBS to capture my other monitor and stuff. Hold on. Great work, OBS. Great work. So the flickering effects are from like on one tick, the logic flows to turn something on, and now it's in like the on state. And then on the next tick, it turns itself off. I mean, I can actually replicate this quite easily. I'm going to sadly reset the simulation here so that, well, no, actually I won't. I'll leave it running for sentimental reasons. If I go in here and just wire a NOT gate to itself, I think I get flickers. Yeah. Because all that's happening here is that the input to the NOT gate is like, if the simulation starts out with the NOT gate outputting true because its input was nothing, then on the next tick, it sees, okay, my input, the node who's providing my input has a value of true, therefore I now have a value of false. That's it for that tick. Then on the next frame, it's the opposite, right? And so it just like flickers back and forth. It's not like infinitely executing. It's executing one pass per tick, per frame, whatever. If that makes sense. One moment. get rid of a few little overlays here. Yeah, probably a good design decision if the Dream framework allowed these sorts of malformed code. Yeah, well, I mean, I think that it's highly undesirable for user logic, user code, to be able to like hang the system. It would just be bad, you know? So it just all runs a single pass. Wow, I'm picking this up to program still. I don't need to do that. I can use a keyboard again. Here, let me just make a new window here. day3.js. Do I really have to save this? Fine, I'll save it to my downloads folder. Okay, getting somewhere. Sorry, I gotta make my font dramatically bigger here. In both the terminal and the actually, tell you what I'll do. I think I will just do that. Easy. There, hopefully that's readable for people. What is my puzzle input? I'm going to okay, there's all my input. Code occurs here. And so this is going to be, let's see here. For, well, let me see first of all, what? First of all, does this get me the stuff that I want? I mean, yeah. Yeah, there was an empty line in there, so okay. We'll go with this. So this is Rucksacks is equal to that. And then for I'm trying to remember if this is how, if you can iterate over strings this way. Kind of. Oh no, right. Oh yeah, you totally can. Awesome. So I'm going to, like I said, literally just replicate my exact same algorithm here, which sucks, right? It's like for I'm going to like loop through, it's like a triple for loop here. For const rucksack of rucksacks. And then for const char of I don't want to think. Sure hope I didn't make a typo in there. This is still not really going to help me, is it? extend at all. No. The hell are you getting this? 01? How is it getting 01? Oh, goddamn JavaScript. Why? Why are these strings? Like, why? Like, why are they? Hilarious. Just hilarious. Oh. Wait, is this not... Wait, don't use... Huh? Wait, what? Ah, oh, God, how do you do this? Is it slice? Is it substring? Is it, what is it, huh? Huh? Oh, it's substring. Oh, and it's start and end this time. Okay, okay, okay. Okay. That's not right. Well, that's nice. Or no, maybe it is. Maybe it is. Hold on. What? No, I'm not doing your homework. Sorry, not gonna do your homework for you. Will this work? Yes! That was pretty quick. That was a hell of a lot quicker than answering it in dreams. That took me, what, 15 minutes? Wow, well, that's great. Four hours and 45 minutes versus 10 or 15 minutes. Yep, that's how Advent of Code goes, I guess. All right, that's good. That's great. That's exciting. Let me toggle back to my PlayStation and shut it down for the evening. So this was an adventure. Thanks all who hung out, stuck with me on this bizarre grind. I guess I'll be back tomorrow. Oh man. All right. This was fun. I enjoyed it, but boy do I hope I don't have to spend 2 hours just working on iteration tomorrow. So I'ma hop off. Thanks all for hanging out. I don't think I'll bother rating anybody with just 4 people. So I'll just call it for the night. It's late. See y'all. Thank you for motivating me, making it worthwhile.